You are welcome back to our mathematics class. Today is going to be the continuation of our set builder notation. If you could recall, in our last class, we started the set builder notation, and I believe you understood it very well. Today, we are going to be looking at more examples, WAEC past questions on this set builder notation. Just before we venture properly into this, if you are a new member on this channel, and kindly subscribe to my channel and click the notification bell for my subsequent contents. For our usual member, I say thank you very much for believing in me, but don't forget to share, like, and leave comments as we dive in properly into this ocean that we are going to succeed in it. So let's dive in. Example 1. Show that question A. Show that set A is equals to x such that minus 4 is less than x less than or equals to 5 is a subset of B, and this B is equals to x such that minus 7 is less than or equals to x less than or equals to 6. Question B, find set A intersection set B. Now, let's first of all solve question A. We want to show set A equals to x such that minus 4 is less than x. From our first lesson, I taught you that change this one to right, from right to the left. So we have x greater than minus 4. So meaning that we are going to start from a number greater than minus 4. And which number is greater than minus 4? That is minus 3. Then we stop at at 5 because this is less than or equals to. And I told you when equals to is being is under that less than or greater than. When you have a line under it, it means you are stopping at that number. Okay? So in this case, we now have x greater than minus 4 will be minus 3, minus 2, 0, 1, 2, 3, 4, 5. Are we there? That is for set A. Then for set B, x such that minus 7 is less than or equals to x less than or equals to 6. Since this one is less than or equals to, if you turn this one, it's going to be s greater than or equals to minus 7. It means you are starting at exactly minus 7 and you are ending at exactly 6 due to this equal to sign that is there. So which means we have minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Fine. When we now look at this one, we are told to show that this set A is a subset of B. What do we mean by subset? Subset means all the elements of A must be in set what? B. Let's look at this. We have minus 3 is here, minus 2 is here, 0 is here, 1, 2, 3, 4, 5. They are all here. Definitely A is a subset of B. A is a what? Is a subset of B. Therefore, x such that minus 7 less than x, Therefore, x such that minus 4 less than x less than or equals to 5 is a subset of x such that minus 7 less than or equals to x less than or equals to 6. So question A done. Question B now says find A intersection B. What do you mean by intersection? Intersection means what can be found in A and can also be found in what? B. Okay, what do you find in A and B? In A and B, we have minus 3, minus 3. We have minus 2, So we have 0, we have 1, 2, 3, 4, 5. So this is the intersection between A and B. Example 2. Let this be a universal set 3, 6, 9, 12 to 30. And set P equals to X such that X is less than or equals to 19. Then Q equals to X such that X is a factor of 30. Where X belongs to the universal set. Question A. What is the number of elements in the universal set? That's question A. Let's look at it. The number of elements in the universal set. Let us list all the elements in the universal set. Looking at the 3, 6, 9, 12, definitely we're talking about factors of what? 30. Or multiples of 30 rather. 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. So we now have 3. So these are the universal sets. Since they are multiples of what? 3. 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 3, 15, and so on like that. Now, the question is, what is the number of elements in the universal set? How many elements do we have there? Number of universal sets will equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10. Question B. List the elements of P union Q. You can't list the elements of P union Q unless you find element of P and element of what? Q. Element of P, X is less than or equals to what? 19. Sorry, the question is X such that X is less than 19. Now, what are the numbers that are less than 19? 18 is less than 19. 17, 16, 15. But those numbers that we want to list that are less than 19 must be present in the universal set, which are these ones. Now let's list the number less than 19. 18 is the first one. Do we have 18 here? Yes. 18 is the first one. Less than 19. Then 17. No 17 here. 16. Do we have 16? No. Do we have 15? Yes. 15. No 14. 13. We have 12. Do we have 11? No. 10? No. 9? Yes. Do we have 8? No. 7? No. 6? Yes. Do we have 5? No. 4? No. 3? Yes. So these are the elements that are less than what? 19. Okay. For the Q, X is a factor of 30. What are those numbers that are factor of 30? Those are the numbers that are also multiple of 30. Number that can go in 30 without no remainder. 2 can go in 30, but there's no 2 here in this place. 3 can go in 30. We have 3 here. Are you there? 5 can go in 30. Do we have 5 here? No. 6 can go in 30. We have 6 here. What can go in 30 again? 15 can go in 30. So we have 3, 6, and what? 15. From here, we can now answer our question now. P union Q. And don't forget the meaning of union. Union means every element in P and in Q without repetition. P and Q. Let me list all the elements in P first. 18, 15, 12, 9, 6, 3. So I've listed 18, 15, 12, 9, 6, 3. Is there any other element that is there that is not here? 3 is there already, 6 is there already, 15 is there. So this is P union Q. Then question C. List the members of P intersection what? Q. P intersection Q means what can be found in P and can also be found in Q. Now, P and Q, what can you find here? 3 is here, 6 is here, 15 is there. So we have 3, 6, and what? 15. So, this is how to interpret this question. If you find this class interesting, do well to subscribe to my channel and hit the notification bell for our subsequent lesson. And don't forget to share, like, and leave a love emoji so that this lesson can go viral. So let us move on to the next question. This is going to be our final example in this class. Example 3. If the universal set is given as x such that 1 is less than or equals to x less than or equals to 15, so x belongs to a set of natural number and its subsets q and p are, meaning that q and p are subsets to this universal set, and q is equals to multiples of 3 and p is equals to even numbers. Draw a Venn diagram to show this information and hence find the elements of the following. This following, we have to look for it. But before we can show the Venn diagram, this Venn diagram, you must find the elements of q and p. Let's find the elements of q. Okay, before then, let's look for our universal set. S is less than or equals to x. When you turn this one upside down, we have s is greater than or equals to 1. Meaning, this equals to means you are starting from 1. But assuming there is no equals to here, it means you are starting from a number greater than 1, which is 2. Okay? But this equals to means you are starting as 1. And you are ending at a number which is 15 because of this equals to. So we have starting from 1. So these are the universal sets 1 to 15. Now set q. They are the multiples of 3. Starting from 3. 3 plus 3 we have 6. 6 plus 3 we have 9. 9 plus 3 we have 12. 12 plus 3 we have 15. So 15 is the end of the universal set. So you can't go beyond that 15 because our universal set that contains this q is ends as what? 15. Then p. P means even numbers. What are even numbers? Number that can be divided by 2 without no remainder. Starting from 2. And they'll be increasing by what? 2. When we start from 2, the next one is 4. Followed by 6. Followed by 8. Followed by 10. Followed by 12. Followed by 14. Followed by 16. But there's no 16 in universal set. So you stop at 14. Now, let us now show our Venn diagram. To show the Venn diagram, let's show the larger box, which is the Venn diagram here. Now, we have two sets, P and Q. The first thing is, before you can draw your P and Q, you look at the Q and P. Do they have anything in common? Do they have intersection? Okay, let's check. Do you have anything in common? We have 2. There's no 2 here. No 4 here. There is 6 here. There is 12 here. Meaning there's anything, we have something in common. If they have something in common, that set will intersect. They will enter into each other. Q will enter into P. This way. Q and P. Now the first thing you now deal with is, what are those elements that can be found in Q and P? In Q and P we have 6 and we have 12. So we have 6 and 12. Okay, when you now remove Q, look at this Q now. Look at my hand. It means taking the Q as taking 6 and 12. If you remove 6 and 12 from here, what remains? 3, 9, 15. 3, 9, 15. Fine. Look at my hand again. Look at this P. If you take away 6 and 12 in P, what remains? 6 and 12. We have 2, 4, 8, 10, 14. 2, 4, 8, 10, 14. These are P and Q, or Q and P. Now, if we now remove all these elements away from this universal set, what remains? Now, all these elements we have, remove 2, remove 3, remove 4, what again? Remove 6, remove 8, remove 10, remove 12, remove 14. So the remaining element will be written outside. And then remove 15 as well. So what remains? We have 5, 7, 9, 11, 13. So 5, 7, 9, 11, 13. So we are able to show the Venn diagram of this question. The next thing is to now solve these questions. Find the elements of the following. All these elements. Let's find it. You can see how easy this is. If you love this class and you want more of this, kindly subscribe and hit the notification bell so that you can see more of this lesson. Then do not forget to share, like, and leave a comment as we proceed. Next question. Question A. You want to find Q prime. Don't forget, we've checked the elements of Q before and the elements of P before. So let me show you that P and Q. Now, Q complement. This means complement. And don't forget what we call complement means taking away the elements of Q from the universal set. The remaining one are our answer. So our universal set is element from 1 to what? 15. When you remove the value of Q, this is Q, from this universal set, you remove 3, 6, 9, 12, and 15. So the remaining one are the complements, which are 1, 2, 4, 5, 7, 8, 10, 11, 13, 14. Yes, 14. So these are Q complements. Question B. We have Q union P. Union means everything in Q and everything in P. Everything in Q, let's write it first. 3, 6, 9, 12, 15. Now in P, 2, 4, we have written 6 before, then 8, 10, we've written 12 before, then 14. So these are Q union P. Question C. Q intersection P, meaning what can you find in Q and you can also find in P? We can find 6, then we can find 12. That is the end. 6 and 12. Question D. P complements. That is, taking away P from the universal set, the remaining one are the P complements. So let us remove this P. Remove 2, 4, 6, 8, 10, 12, and 14. So let's write the remaining one. We have 1, 3, 5, 7, 9, 11, 13, and what? 15. Question E. Q union P complements. Q union P complements. We have gotten our Q union P before. Q union P. Then taking away Q union P from the universal set, the remaining ones are our complements. Okay, Q union P. 3, 6, 9, 12, 15, 2, 4, 8, 10, 14. So what do we have left? We have 1, 5, 7, 1, 5, 7, 11. That is it. So this is E. The last question and 13. And 13. Thank you. And 13. So the last question F, P minus Q. This is called difference of sets. How do you go about difference of sets? Means all the elements that are intersects in Q. That is, element that can be found in element of P that can be found in Q. When you now take it away, the remaining one in P is your answer. Meaning, look at this P. Element that can be found from P to Q. P in Q. Element of P in Q. We have 6. Then we have 12. So when we take away 6 and 12, that is, this is P. Take away 6 and 12 because it can be found here. The remaining one here in that P, they are your P minus Q. That is 2, 4, 8, 10, and 14. So this is P minus Q. So this is how to go about set builder notation. I remain your tutor, Lateef Ismaila Akanbi. Don't forget to subscribe to my channel and leave a comment as you leave. Don't forget to also share, like. Thank you very much. We meet in the next class.